A particle P moves in a straight line such that its displacement x at time t is defined by the differential equation given. At time t is 0, x is 1 over e. By using Euler's method with a step length of 0.1, find an approximate value for x when t is 0.3 seconds. First of all, you should understand that this dot means the derivative with time, so it's dx over dt, and don't get confused. Here it's cosine of t and then multiplied by e to some power, not cosine of such an argument. And according to the Euler's method, formula is given in the data booklet. The next value of function, here it's x depends on t, so xn plus 1 is equal to the current value plus step, here it's 0.1 multiplied by the derivative at current point. And definitely we can calculate using Euler's method only with the calculator. So first of all, you should choose radians. There must be radians and sequence here, not function, sequence. Then we choose y and let u be x and v be time. And notice that here we use n, v of n, it means time of the next point, and v of n minus 1, it means time of the current point. So O n minus 1 we use for the current point, O n it means O for the next point, and V it's time, so V of n is the next point of time, it's the current point, V of n minus 1, and notice that you must always write V or U of n minus 1 for the current point, plus a step, it's 0.1, and V of n mean is 0, it's the initial point of time, it's 0, and it's clear that the next point of time is 0 plus 0.1, the next 0.1 plus 0.1, and so on. U it's x, and you can see that un it's x, and the next x value it's the current value of x, u of n minus 1 plus a step, it's 0.1 multiplied by the derivative, and derivative dx over dt is given by this expression. And you can see it's what x, it's u of n minus 1 multiplied by cosine of t, and t it's v, and there must be v of n minus 1, and there must be correct number of parentheses, and then multiplied by e to the power of negative sine of t, and t it's v of n minus 1. And then just second table, and we can see v it's t, u it's x, and we need what? X at t is 0.3, so you can see t is 0.3, x is 0.477 to 3 significant figures. So x at 0.3 is approximately 0.477 to 3 significant figures. In general, there may be some units of length, but here there are no units. The next, by solving the differential equation, find the percentage error in the approximation for x when t is 0.3 seconds. You know that the percentage error formula is given in a data booklet, that is the absolute value of the approximate value minus the exact value, and then divided by the exact value and multiplied by 100%. So we need to solve the differential equation. Let's rewrite it. It looks like dx over dt is equal to x cos of t e to the power of negative sine of t, and we can solve it by separating variables. We move everything with x, for example, to the left, with t to the right. So it becomes dx over x, divide both sides by x, and cosine of t e to the power of negative sine of t dt. And then we integrate both sides. And we can consider indefinite integrals or definite. Let's consider both methods. So if we consider indefinite integrals, anyway, we need to integrate both sides. So on the left hand side, we can see it's directly expression from a data booklet, and it's integral 1 over x dx. It's ln of the absolute value x plus constant, and integral cos of t e to the power of negative sine of t dt. It can be found using method the substitution u, and actually it's the only method that you should know. Otherwise it should be calculated with a calculator, but notice that calculator can calculate only definite integrals, and limits must be numbers, not variable. Not for example, calculator cannot calculate integral from 0 to some t of some expression, something like that. And notice that for some problems they may be solved using definite or indefinite integral, but there may be such a situation when you try to use indefinite integrals, but this expression cannot be integrated without a calculator, and there must be limits which are numbers, and then you should use definite integral instead of indefinite integral, and so that you can just calculate with the calculator and get just a number, and something unknown will be on this side, something like that. Okay, so how to use substitution u? So we denote u to be what usually, and actually how do we understand that we should use substitution u? Because it's not a function directly from a data booklet. So we try substitution u. If you try to do substitution u and you cannot get a result, or you cannot get rid of t and get integral in terms of u only, and it must be from expression from a data booklet, what does it mean? You should announce the substitution u, so your substitution u is not correct, or it cannot be solved or found using this method at all. So, and usually if we meet some usual function but more complicated argument, we know function e to the power x, but here we can see e to the power of sine, negative sine, and it's more complicated argument, and usually this complicated argument should be used as u. Also, if you meet division, usually denominator we choose as u. So u is negative sine t, then we find derivative du over dt. Over dt because it depends on t. And sine derivative is cosine, so it's negative cosine of t. Then we solve for dt, and dt becomes what? Du over negative cos t. And then our integral becomes. In general, if you use limits, and in terms of u, limits also change. But you may then rewrite in terms of t again, and the limits will be the same. So cosine, you can see that u is negative sine, but you don't hurry up, because if it's not useful to, or it's not easy to change in terms of u. Why? Because you know that this method suggests that such functions, expressions will cancel. So we keep this cosine, or actually you may substitute it later. E to negative sign, which is u, and it is du over negative cosine t, and you can see that this cosine of t cancels, and we get negative e to the power u du, and it's directly from the data booklet. E to the power of x integral is the same, so it's negative e to the power u plus constant, and it becomes negative e to the power of negative sine of t plus constant. So our expression becomes, notice that it's enough only one constant. It's not necessary to write two constants, because if you move this constant to the right, there will be constant minus constant, it will just another constant. So it becomes ln of the absolute value of x is negative e to negative sine of t plus constant. And to find constant, we need some point. Here it's t, when t is 0, x is 1 over e, and you may find constant now, or you may solve for x is, and then find a constant. It doesn't matter. So when x is 1 over e, it becomes negative e to negative sine over 0 plus constant. Sine of 0 is 0, e to the power of 0 is negative 1, and you may calculate it with the calculator, and 1 over e is positive, and we can just write without this absolute value bars. And you remember 1 over e is what? E to negative 1, but there is a property for logs that this power moves in front, so it's negative 1 ln of v, and ln of v it's log to the base e of v, and when this is equal to this, it's just 1. So it's the left hand side is equal to negative 1. And you can see that c is just 0. And about the absolute value is just this expression under the bars when x is positive and negative x when x is negative. But since we can see initial point is positive, so we can suggest that x is positive, or anyway, how to undo ln. You remember that log to 8 is equal to 3. Why? Because 2 to the power 3 is equal to 8. Here ln it's like log e, so 2 is e, 3 is this, and 8 is this, and c is 0, so it becomes ln is equal to negative e to negative sine of t plus 0, and e to the power of this negative e to the power of negative sine of t is equal to the absolute value of x. But if x is greater than 0, x becomes e to negative sine, and x is less than 0, x is negative e to some power. But e to some power is always positive, and graph looks like this, and minus in front, it means that there will be negative value. And if we consider t0, x will be negative, so contradiction arises here. So x is positive here, so we should choose, and we can write just what the just x here. And you can see if we substitute t0, we get 1 over e. So it's the exact solution, and we need x of 0.3, so it becomes e to the power of negative e to negative sine of 0.3, and you just calculate it with the calculator, but notice that there must be radians only, not degrees, and it is equal to, notice that it's the intermediate result. We don't need to round it to 3 significant figures because it will be used later when we calculate the percentage error. So it's 0.47510 and so on. And if we use definite integrals, x changes from what? The initial value is 1 over e to some unknown value x. We can write capital X, it doesn't matter. And t changes from 0 to 0.3. And you should do the same integration, but notice that here these can be calculated directly with a calculator. It's not given that you should calculate it by hand, but the left hand side becomes ln of the absolute value of x and limits from 1 over e to x, and is equal to some value which is from a calculator, it's 0.255855 and so on. And the left hand side, remember that how to calculate this expression. We substitute upper value, so it's ln of x minus ln of 1 over e. And the same reason, x is initial point is positive, so x is positive, is equal to the value, and again 1 over e, you may calculate with the calculator, or it's just -1, so it becomes ln x plus 1 is this, and move 1 to the right and it becomes ln x is something, that e to the power of something is equal to x, and then you consider x of 0.3. And you get that it becomes e to the power of negative 0.744 and so on. And hence also we get the exact value, and it will be the same 47510 and so on. The same result. Then the percentage error is what? The absolute value of the approximate. It's our this, but it is rounded to 3 significant figures, so we should take more decimal places, so it's 0.476548 and so on. Definitely the final answer should be rounded to 3 significant figures, so 4 or 5 digits will be enough, minus the exact 0.475140, so on, the absolute value, and divided by the exact 0. the absolute value for all expression for 7, 5, 1, 0 and so on, and multiply by 100%, and you get 0.296% to 3 significant figures. And that's all for this question.